As part of the IIT Mumbai OER, we would like to introduce today object-oriented concepts. Let us start with a simple quiz question. How do you represent a student in the software world, say in a C++ program? Let us remember that student is an entity in real world who gives an exam or attend lectures and so on. Can you identify the concept involved here? So typically the answer would be that in a C++ language, we would represent student as a class and capture the student's age, address, the subclass that he belongs to, the subjects that he would like to appear the exam for, and attendance and so on. This concept is called abstraction. So can you name some more core concepts? And if you can do so, can you identify the concepts involved? Can you illustrate them with examples from some application? And finally, can you identify how these concepts can be represented in a language like C++? The agenda today will be to introduce you to the basic object-oriented concepts. There are many object-oriented concepts. The important ones are abstraction, encapsulation, information hiding, generalization, specialization, and polymorphic behavior. So, one more question. How do we abstract real-world entities into various languages and systems like databases or languages like C++? This concept is called abstraction and it's a simple way of describing a real-world entity equivalently in a software world like C++. The idea here is to abstract away the details in order to be able to focus on what is important. In sports, the student's cricket score may be important. In examination, the subjects that he appears for may be important, and so on. For example, in an online shopping application for selling books, some of the abstractions, that is, some of the classes and objects would be book, order, shopping cart, and so on. Next, let's look at this dichotomy of classes and objects. Typically, as human beings, as kids, as toddlers, we are first introduced to objects as toys, and it's pretty natural to think in terms of objects. So, thinking in terms of objects is pretty natural for us. In database world, we have encountered entities like the person, employee, part-time employee, full-time employee as abstractions. However, classes are considered to be a more advanced abstraction because they not only capture the characteristics as entity, but they also capture the behavior of the student or employee and so on. So, the objects and classes are two different things. Objects are considered to be instances of classes, and classes are considered to capture and model the similarities between objects. We also typically say that objects have behavior, objects have characteristics, and objects have state. For example, a student has age as a characteristic, could be in the first year, and that could be the state, and may attend exams, and that could be the behavior. The next concept is encapsulation. Classes act like an encapsulation unit, packing the behavior and characteristics of objects together. For example, we can capture the sportsman's ability to play cricket as well as score runs as an object called as student or a sports person. Encapsulation is the packing of data and functions into a simple component. This is one more way of saying that the data and the methods is brought into one encapsulation unit called as a class. Another object-oriented concept is information hiding or data hiding, and in programming in object-oriented world, this is considered to be protecting the data from any inadvertent change throughout the program. So let's take an example of accessor and mutative methods. An accessor is a method that is used to get some information about the object through the get method, And mutators are public methods that are used to modify the state of an object while hiding the implementation of exactly how the data gets modified. These are typically setter methods. So for example, get age will get the age of the student, and set age will be able to modify the age of the student subsequently. Encapsulation, therefore, is hiding unnecessary data in capsule or unit, and abstraction is showing essential features of an object. So if we were to calculate salary for different kind of employees, part-time and full-time in an organization, how best do we model this in a programming language like C or C++? There are two concepts involved here: the specialization of the employees into part-time and full-time, and the behavior of how to calculate their salary differently for part-time or full-time employee involves polymorphic behavior. So, can you identify the following concept? How do you capture the similarity and differences amongst various kind of students, like computer students, electronics students, or undergrad students and postgrad students? Typically, again here, the concept involved is the inheritance or the relationships, generalization, specialization. So, an example here would be the product can be either a food product or a toy product in a shopping application. This would be an example of specializing a product into food products and toy products, or generalizing various kind of products into the product category. The next concept is of polymorphic behavior, and informally it can be seen as referring to the ability of a message to show different behaviors at runtime based on which object receives the message. So a part-time employee, if it receives the message calculate salary, would have a different behavior of how to calculate salary, and a full-time employee would similarly have a different approach to calculating salary. So this is an example of all these concepts which are related together. So in this case, you can see a form which has been specialized into an expense form or a loan form or a purchase form. This forms a class hierarchy, and the behavior which is polymorphic is how do you calculate the loan interest, or how do you calculate the expenses, or how do you calculate the purchase amount. This could be a polymorphic behavior. Another example of polymorphism would be that if I were to call or send a message to a drawable object or a shape object to draw itself, then depending on whether it is a triangle or a circle or a square, the way it will be drawn will be actually a different behavior. So to conclude, we have looked at the various object-oriented concepts. Thank you so much, and we'll continue with this series of sessions or lectures. We'll introduce to other concepts like the how C++ examples can be given for object-oriented concepts, how in a given application you could identify classes, and so on. Thank you so much.